Welcome to the On-Premise IT Podcast, the only podcast that dares to be both on topic and on location. Each time we meet, we bring you the perspectives and opinions of a group of IT experts in their field. On today's episode, which is brought to you by Keysight, we would like to introduce our panel before we jump into the premise for today's episode, starting with Tim.
Thanks, Tom. I am Tim Bertino. I'm a principal data architect in the healthcare space and also co-host of the Art of Network Engineering podcast.
Hi, I'm Nick Buraglio. I'm a network architect for a large research service provider and also the co-host of Modem.show podcast.
All right, and joining us from Keysight is our special guest, Charles. Charles, would you like to introduce yourself?
Hi, I'm Charles Seifert, Senior Manager of Product Management for the Hardware Platform Electronics, and I specialize in high-speed Ethernet testing.
Well, thank you very much for joining us today. Let's jump into the premise for this episode. Now, you've probably seen that Ethernet speeds are ever increasing. We're not dealing with your mom's 10 meg regular Ethernet anymore. We've seen speeds of 100 gig, 200, 400, and now even approaching the terabit Ethernet speed range. But how do we make sure that everything is going at the speed that it's supposed to? How can we make sure that everything is working the way that it's supposed to? Do we just plug things in and hope for the best, or is there a better way to do it? The premise for this episode is that network testing is still critical. And Keysight has a little bit of a, I don't know if you call it an expertise in this area over the years, but I want to open up by kind of asking Charles, what do we mean when we say network testing? Why is it so important?
Well, that's a very good question. From the business perspective, which later on boils down and bubbles down into the technical arena. If, let's say I'm Microsoft or Amazon or Google, and I want to upgrade my network infrastructure, my network hardware that operates the network, and I want to move from 100 gig E to 400 gig E, or 400 gig E switches to 800 gig E switches. When I go to do that, I want to be sure before I deploy that equipment, and I'm going to buy thousands of these switches and routers and servers and NICs. Before I do that, I want to make sure they operate and meet the specifications published by the manufacturer, and that they meet the design criteria for the network infrastructure topology that I want to deploy. That's the most important thing.
Now, I kind of want to jump in and ask Nick here, because Nick, you've worked with some pretty large service providers. Do you guys install equipment without having certified tests?
No, we have a large battery of tests that we run in a fairly good sized lab that varies from virtual testing, for protocols and configurations and automation, all the way up through an actual physical hardware lab that has permanently installed testers that run a gamut of tests through things. We also will ask for proof of concept labs and things like that, and then take those and then also sort of build on what we already have. So there's a lot of testing that goes on before anything gets installed.
Yeah, I would agree that that's super critical. But we talk about testing in kind of a broad scope. I want to dig into a little bit of the detail here. So is it just bandwidth testing? Are we just talking about whether or not the thing is wide enough to actually do that? Or are we doing other kinds of testing like load testing with very specific applications?
Well, actually, we're doing things all the way from the network link layer, so the data link layer and the OIF model. So that means that layer 2 and layer 3, where we have what we call our data plane traffic. And data plane traffic would be something like email traffic, for example. That has to be tested. The links between switches and routers and switches and servers has to be tested for long-term reliability and stability. And we move to these very high speeds. The complexity of the measurements we have to make increases dramatically over legacy speeds, 100 gig E and slower. Above 100 gig E, it becomes very complicated. And we have new measurements that we need to make to ensure that those links are stable, so that we can run the upper layer protocols over top and not have to worry about throughput, reliability, or stability.
Tim, I know you've had a lot of experience working in networks. Have you ever seen a situation where a link, they say, oh yeah, it'll take all of this traffic, and then all of a sudden things fall over because, oops, it turns out we tested the wrong thing?
I do think that's important because you mentioned it a minute ago, Tom, when you talked about are we really just talking about bandwidth testing? Because I think that is what people usually think about when they talk about certified gear. We want to make sure that this network gear is going to work at specific speeds, but it's so much more than that. And it's more than that because we don't just run raw data. We run protocols. We run things that take time and incur latency. So we want to be able to test those different things. So I do think it is important. A question that I have for Charles is kind of twofold. First off, we talked about the in your example, like a Microsoft or a big company that wants to be able to test gear for a big upgrade. To me, at that point, those big companies would be the customer. Is network testing prevalent in other facets as well? For instance, manufacturers, are they testing their gear with specific tests as they build? And at what time does that happen? At time of design and initial build, or manufacturing? Can you get into that at all, Charles?
Sure, Tim, it's all of the above. We use our test systems that we're talking about today, specifically the Aries 1 800 gig layer 2-3 test system. We test silicon. So a silicon device like a switch ASIC or something called a PHY chip, we just generally call that. We test those when they're in their on their development boards. When those chips move from a development board to a switch fabric, a layer 2 or layer 3 switch fabric, we test the switch. When those chips move to an optical transceiver or an active electrical cable, where we have a chip that assists the signals across a copper cable, we then test the optical transceiver, which uses fiber, and we test the copper cable. And then when we have switches and servers connected together, we have to test both at the same time. So we'll test servers, switches, how switches upload data to servers and servers downloading data back to switches, and how that all works together. All of that, which we call a system under test, has to be tested. And then finally, we test the edge routers and core routers, in order to be able to know that the network infrastructure is delivering the complete payload with protocols in a stateful manner at the bandwidth, the rate of bandwidth that we want to produce on that router. So if we need a router connecting two campuses together with a trunk line of 400 gig E or 800 gig E, we want to make sure we know what bandwidth we're getting through that trunk line. Otherwise, we'll slow down the entire network infrastructure that was before that.
So it sounds an awful lot like what some of the things you're doing where you're testing the individual components and then you're testing them together. It sounds an awful lot like the software development cycle. If, we're doing functional tests, then we're doing unit tests, then we're doing system tests. But I also know that in software development, at least as of late, there seems to be this mantra that I keep hearing in the background of move fast and break things, try stuff. Let's just throw it at the wall and see what sticks. And I know that works really well in software because, hey, code's free, right? I can just do whatever I want. But does move fast and break things really work that well in hardware?
Well, no. In fact, what we call the layer 2-3 network infrastructure, basically it has to be rock solid. It has to be 100% reliable for a long period of time, years. Okay. Now, the other part of that is we do not want to turn over networking equipment over to software groups that are integrating very complex protocols, unless we know we've given them a very strong base, a high performing base of hardware, so that they're not trying to fix bugs they can't fix. So if there's a hardware problem or a link problem or a forward error correction problem that 800 gig and 400 gig ports need to run, and there's a problem there, they can't fix that at the protocol level. That can't be fixed with just software. This is at the firmware level. This is software that runs on chips or ASICs, or it's the actual silicon that's communicating from one port to another port between two link partners. And let's remember, we're talking about companies that have thousands of switches and routers. Companies that are like the cloud service providers, they're now supporting greater than 2 million servers each and growing to 3 million rapidly. Imagine that. So we want to deliver hardware that's solid.
I think it's also important to realize that the software lifecycle is significantly shorter as well than you sort of hinted around about this a bit, but the hardware lifecycle is in the order of years rather than the order of months. So to spin up a hardware silicon chip, the fabrication process involves manufacturing, not just compiling. So there are physical things that have to occur that take long periods of time. So you don't want to you want to make sure that you don't have to repeat that process, because recasting your silicon is not great for manufacturer.
What's interesting at 400 gig and 800 gig is that testing for bit error rates, forward error correction performance is mandatory at 400 gig and 800 gig. And from the silicon to the silicon on a board, to the board itself, to the board installed into a switch, to the switch installed into a pre-deployed network in a lab, we have to test, and we basically do pretty much the same tests at each level throughout that entire process, from silicon to the final manufactured product, to the product shipped to the actual network operator who uses the product and qualifies it prior to deployment. Pretty much the same tests are run at every one of those points. And for example, a manufacturer, let's say like a Cisco or Arista networks, they cannot build these products without testing. They can build them, but the risk of not testing is so high, and post-deployment correction is extremely expensive. It costs less to develop the product than to fix a few dozen problems in the field.
To that end, Charles, I want to get into some of the processes and best practices of network testing. We've brought up the software development lifecycle and how there are frameworks like that are in place for software development. Is there anything similar on the network testing side that governs how these manufacturers and then customers of network testing systems deploy and develop this testing?
Absolutely. We use regression test beds where we have a fixed number of tests. Now, by the way, we're talking about 100 to maybe 500,000 tests that are run to qualify a network switch or router. Okay, this is not an insignificant task. So yes, there's test automation, automated test harnesses, and those harnesses have certain revision, let's call, of our test system, our test hardware with our test software, and then test automation like scripts that are written in automation frameworks that use Python or the REST API or Python language, and they will run these tests over and over again. And let's say we're testing our switch and the manufacturer sends us a new firmware or a new iOS operating system to load on that switch. Guess what? We got to run that battery of regression tests all over again before we deploy that. So yes, we have to do repetitive testing called regression testing. We have to do unit testing and feature testing prior to that to even get a regression test bed qualified. You have to do all the unit testing, all the feature testing, all the electronic verification testing. All that has to be done first. Then you put it in regression. Then we start testing network equipment. And then every time we change that equipment or change the topology of that equipment, we want to test it again.
I think it's a valuable point to underscore there, Charles, because let's be fair, we deal with a lot of network engineers who are maybe not familiar with testing. And when you say network test, they hear iPerf or other like kind of free or very limited tools. What are some of the things that you guys test for that would be outside of the purview of a very simple app like iPerf?
Well, one of the most important things that we do is what we call throughput testing. And throughput testing means how much actual data, regardless of the overhead required to deliver the data, how much actual data is really delivered? And what is the user experience when that data is delivered to that person, right? So I'm out here and I'm using some application on my phone, my smartphone, and all of a sudden it delays for 30 seconds. I'm not going to be happy about that. My user experience is unpleasant at that point. My expectations are high. Well, if the network infrastructure is not delivering, if the protocols are not delivering, if the servers are not getting the data through out to the trunk links, if we're not, in other words, there's so many pieces that have to work together properly, but it all boils down to user experience. What is the effect? If I drop packets in the network infrastructure, I see blips on my video. If I drop packets and I'm on a Teams call, my friends in the call can't hear me. They say, "What happened? Your voice dropped out. You cut out." Well, that's a latency problem or a delay problem or a jitter problem. And we can test all of those things prior to deployment under tremendous stress, under the stress that actually exists in a real network. We can stress in the lab.
Another point I want to bring up here, because this is something that I've kind of run into, at least in my previous career, is the idea of retesting. And I'm sure Nick and Tim will agree with me here. A lot of times you deal either with your own company or with a customer that you're working with, where they went out and they bought the biggest and baddest thing that they could at the time, and it has modules that you can plug into it later, and they say they want to run it at 100 gig today. Well, now it's time for a refresh. And they're like, well, we're not going to refresh the whole equipment. We're just going to refresh the optics and the modules so we can upgrade this to 400 gig. And then it suddenly doesn't work at 400 gig. And now they're screaming at you. Why didn't you told me to buy this because it was big and expensive and now it doesn't work. Where is value in that chain to add a testing platform like Keysight to come back and say, well, the reason why it's not working is because you guys used crappy fiber, or that this module isn't rated for those speeds with this particular configuration? Is there a way for Keysight to, in effect, provide me defense against the whole, it should work because we paid a lot for it?
Absolutely. In fact, with a platform like the Aries One 800 gig system, which we call Aries One M for multi-rate Ethernet, because it supports 10 gig all the way to 800 gig and all the speeds in between, we can take any new optical transceiver, any new copper cable, any new active electrical copper cable, plug it into the system, turn it to the speed that we want to test with, and try that new optic or that new speed. But we have to have the test system capable of doing that. And the Aries One M system for 800 gig is the only platform that has 10 gig to 800 gig and all 11 speeds in between, including something we call fan out speeds, where a single port on the test equipment can fan out to, let's say, 8 100 gig E ports, or 4 100 gig E ports, or 2 200 gig E ports, and so on. That's called fan out testing, which is used extensively now in network infrastructure, like a middle of rack switch, for example, or a top of rack switch aggregation switch that might be aggregating to a bunch of 100 gig E servers, but yet it's a 400 gig E switch. So multi-rate Ethernet testing is critical. And now that we're at higher speeds of 400 gig and higher today in deployment, the forward error correction testing, the bit error rate testing is extremely important to understand what the reliability is of all of those links and these very complicated fan out speeds and so on.
I want to take that apart a little bit more and sort of bring it into the realm of let's say an implementer or an operator, right? So you've got you have this switch or layer 3 switch router, whatever you want to call it, and a lot of network engineers can relate to that have been around a little bit of time, the limits that existed on some chassis platforms where you can pull out a card and then you throw in like a 4 by 10 gig card, but you're never going to get more than 20 gig through that. But it's hard to find that information, right? So this type of testing aids in figuring out, what your actual, if your line cards and your chassis are non-blocking, it tests port buffering, which is incredibly important for, especially for large flows, but also for long-lived flows. And it helps you test things like your backplane fabric and your crossbar that often are, something that are just assumed to be whatever level of support the cards are that you put in there, which they may or may not be. So it helps test existing and future performance across the entirety of, let's say, a deployment in a data center, from the level all the way through the buffering and the crossbar and all those things that we often forget.
That's right. And with the spine and leaf network topology design, which is very popular now, protocols like ECMP, link aggregation control, LAC. So when we do link aggregation control, we now get into a statistically based throughput, and that has to be measured, because I can't just assume that every port will work at 100% when I'm doing link aggregation. So now I wanted to set up my test system to run link aggregation, to run ECMP for the many-to-many, many-to-one network configurations, the different topologies, one-to-many, many-to-one, many-to-many, fully meshed, partial meshed. So in order to do that, you need a test system that has software to configure those, as well as the proper hardware and the Ethernet speed support to run the traffic, whether it's stateful protocols, stateless protocols, networking protocols, or traffic itself, to run that in real time simultaneously.
I want to touch on something that Nick brought up there, because I also think that that's important, kind of going back to my question about recertifying a network to operate at higher speeds, is recertifying a network to operate with different application loads. Because one of the things that we've seen, and I'll be the first person to call this out, how many times have we looked at the stats from, say, a firewall device, and you're like, oh, well, it has this many packets per second throughput. And then you dig into the test results, and it's like, oh, it's 64-byte packets. Nobody sends 64-byte packets. Whereas if I'm in a network and I'm like, okay, well, I've got, an average level of flows that could be a lot of HTTP traffic, or it could be a lot of things that are north and south facing headed to the cloud. And then I want to develop new workloads, something that's, cutting edge, that are longer lived, larger flows that are very insensitive to delay and latency. How can a testing mechanism like Keysight's help me say, we've got issues over here with maybe it's a blocking uplink, or we need to enable ECMP to make this work a little bit better, because if we don't, that giant flow is now going to cause massive latency issues across the whole network?
Well, Tom, the answer to that question, unfortunately, is a long answer. So what I'm going to try to do is to kind of simplify it just a little bit. When we talk about flows, the assumption would be that if we have a network infrastructure already in place, we have some idea of what the traffic profiles are. What's my percentage of HTTP? What's my percentage of email, fax, video, streaming, gaming, all the different applications. So typically there's something called network monitoring that goes on. And if the operator has some clue as to what's the percentage of traffic that's going through the network test system can actually be set up to emulate that mix. Now we have standard tests called Internet Mix, iMix, which is very popular to run data plane testing. But we also have something that works the way a multi-services router works, in the fact that we can run networking and internetworking protocols at line rate with mixtures of traffic, mixes of traffic, profiles of different traffic simultaneously. So if I take my profile and I put that in the test system, and let's say I want to run BGP, right, Border Gateway Protocol between routers, and I want to know, does that profile make it through all of the hops in that network? Does it make it, and what throughput does it make it? We actually can measure that in real simulation. You don't have to be in a real network to do that. You can be in a test topology in the lab and really understand what that is. And I think a lot of network engineers are not familiar with these advanced testing concepts because they never were exposed to it. And hopefully we can educate people to learn how to use all the capabilities that are built into our systems, like the Aries 1 800 gig system. It can do those things at 800 gig line rate.
Well, as you can see, network testing is not as simple as running downloadable applications. There's a lot of things that you have to consider and how all of those pieces integrate and work together. And you need expertise in that area in order to make sure that you're rating this at the proper area that it needs to be done. This isn't as simple as plugging in a cable and crossing your fingers and hoping that it works. And if you're investing millions upon millions of dollars into thousands upon thousands of devices, you better know that it's all going to work together, because it's your butt on the line if it doesn't. Now, Charles, you've mentioned the Aries platform a few times in this podcast. I was wondering if there was a place where people could go to learn more about what Keysight is doing in this area.
Absolutely, Tom. At Keysight.com, just go to the search and type in ARESONE, Aries 1 space 800 gig E, and it will take you to the product page where we have all of the highlight information, photographs, and collateral resources available in videos to learn more about testing from 10 gig E to 800 gig E with Aries 1M.
Thank you, Charles. And we will include a QR code for you to scan to get to that URL, as well as including a QR code that will take you to some more assets and resources, including a link to a webinar that you're going to want to check out. That will just about do it for this episode of the On-Premise IT podcast. We want to thank Keysight for bringing you this episode, and we want to thank our guests for joining us. You can always find the latest episode of this podcast on our website at gestaltit.com/podcast. You can also subscribe in your favorite podcast application of choice. We debut new episodes every couple of weeks. If you would leave us a rating and a review, we'd really appreciate it. It helps people understand some of the great topics that we talk about here. We should be back with another great episode in a couple of weeks. Until then, please make sure you check out our website at gestaltit.com for more great information. And please make sure to check out the show notes to learn more about Keysight and all of their great solutions.